So good evening, guys, or anything. Good morning, good evening, good night, guys. So, not good night, good evening, and good morning, guys. So, we are solving C programming functions questions like okay, good questions on functions, right? Let me just join here. Okay, so just a second. Don't see. Let me just a second. I'm just joining a meeting. Means I will just join so that I can screen share, right? Okay, so let's join. So copy this. Yes, paste here. Yes, yes. So share rooms out. No. Okay. 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 So guys, let me screen share this. Okay. So guys, let me screen share. Let's start our discussion. Right. Let's start and let's not waste time anymore. Let's not waste much more time. Okay. So continue. Start now. So let me just zoom into this. Okay. So where is the zooming option? Full screen. Yes. Don't need this. Don't need this. Right. So let's just read my screen. Notes. Okay, guys. Not now. Yes. So we were doing question 2. Okay. So actually, can I make this? Just a second. Actually, do this like this, and this one, and this one. Yeah. So I think you can see the boat. I think you can see boat. Okay. So question 2. This one is question 2. So the question, I think you can hear my voice. Yes. Okay. So question 2 is saying, write a program to find the factorial of a number n by using a suitable user-defined function. Right. Suitable user-defined function. So we will start with writing int main. Then we will write int declare n. Then we will just print this number, printf enter a number, just this. Then we'll just scan this because we need to save it, right? %d, and you just save it in n only, right? Then we will write if n is less than 0, we will write printf factorial of negative number is not defined. Factorial of negative. So of negative numbers is not defined, right? Okay, we will not Okay, now why we didn't use curly braces because it's a single liner, and we will also not use it for else, because if you just don't believe me, you can just see here. Just Gemini. Okay, in curly braces in C, curly braces are optional if else for or while block contains only a single statement. It is optional if curly braces are optional if else for or while block contains only a single statement. So if these all contains a single statement, all these block if all these blocks contains a single statement, and we will curly braces are optional. Okay, let's just continue. Right, can I just zoom this? Actually, just make it a bit smaller. This one looks better. Right now, okay, then we will let else factorial n. So what is this? This one is actually your function. It will just call a function. Now we will write, because when we call a function, only the variable goes up, right? When we call the argument value, because this is known as, actually, even though this one is called as argument, and once it is getting called and it goes up there, it would be called as the argument becomes parameters after the call, right? Okay, when we call the argument values, this one, when we call this value, right? When we call the argument values when the argument values goes into a function, its data type doesn't goes. It only variable just goes up, right? And we have to declare it again. So we will declare the function again. We will write here. We will write here what? We will write here just hashtag include studio. Right. This one is basic. Okay. We will write here void. We will write any name. Not any name. That you have given this name. So it's factorial. This is function, and we'll let int n, because only n goes up, data type doesn't goes. We have to declare it again. Then we will write here let's start. Okay, now int fact. Then we just make it false. Okay, what full screen would be just, okay, no, I don't need this. Yes. Now int fact will take one variable which is named as fact, and we'll declare it, and it will take the value 1. Then we will move on. We will just declare a for loop where I will be equal to 1. Where int I, declare it again, declare another new variable, and we'll just take I is less than equal to n. Okay, is my video on actually? Just a second. Let's switch it off. Okay, so everything is all right. Yes. Okay, right. I equal to 1, I is less than equal to n. Then we will write I plus plus. Then this is right. and because again we will write one error, we will not use curly braces, then we will write fact is equal to multiplication I. Okay, sorry, I'm wrong. Multiplication equal to I. So okay, so what it is saying is fact, this is actually fact equal to fact multiplication I. So basically we will take I as 1 and fact as also 1, so 1 times 1 is 1, and how much and for how much time will it continue, like what, for how much time this I would increase, like I, let's say n is 5. If n is 5, you have inputted here 5, it has gone here, right? So I would be less than equal to 5. So basically I would go on increasing 1, 2, 3, 4, 5. Would just keep on increasing, and and it would just, what will keep on increasing? I would keep on increasing. So and fact would also keep on increasing, right? So now fact is, okay, let's actually write to make it complete, right? So let's see here. So fact would be, let me just take it over here. Just a second. Okay, so fact would be 1, then it would just get multiplied with I would be also 1 into 1, fact would be 1, then it would again just go then I would increase by 1, then we will get fact as 1, so here it would be 1 because this is fact. I told you this one, let us write it again, fact equal to fact times I, or you can just exchange also, but let's do this. Okay, so fact is 1 multiplied by I is 2, then fact would be 2, right? So fact would be 2, this new fact, we will write the fact here again, then the I would be 3, then we will just get new fact as 6, then we'll write this right here 6, okay, we'll write here 4, okay, so fact would be 24, and fact would be, we'll just write here I as okay, let's just actually not write like this, we'll just write it 3 times 2 times, because it's 6, right, times okay, what was this, 2 times 2 times okay, let's just leave it like that only. Just a second. 6 times 4, okay, now fact would be 24 and it would be 5, that's it. So 5 factorial is what? 5 factorial would be, let's see my calculator, 5 factorial would be 5 times 4 times 3, sorry, 5 factorial would be 5 times 4 times 3 times 2, this is 120. 24 into 5 is what? 24 into 5 is also 120, I guess. Yes, so it's 120. Okay, so what's the logic behind this? So basically logic is simple. That fact is we needed 5 factorial, 5 times 4 times 3 times 2 times 1, but what we are getting, this is fact, okay, this is fact is 5 factorial, So 5 factorial we are getting here, that we are getting first 1, then we are getting 2. No, actually fact is getting updated, right? So 24 into 5 is basically 5 times 4 times 3 times 2 times 1. Okay, so then we'll just return nothing, and it would just be printf factorial. Yeah, just a second. Just a second, I'm coming up. Okay, let's continue, guys. Just a second. Okay, well, let's continue, people. Right. So I was telling you So fact equal to fact times I means what? I would be increasing. Galaxy bag एथर गई देखा है guys, sorry for being late. Okay, so I think I'm audible, right? Okay, so guys, So okay, so I was telling you that this fact would increase. ମମେ ମତେ ଆଉ ଡାକିବୁନି ହେଲା, ମୁଁ ପଢୁଛି ଆଉ ଡାକିବୁନି, ବୁଝିଲୁ? ହଁ okay, so this fact would increase. Which fact I'm telling about? I'm telling about this one. This fact would increase. How will it increase? It would actually we are just finding this fact only. Okay, so this fact is dependent on what? Dependent on I, right? I would increase 1, 2, 3, 4, 5, right? And we need that 1, 2, 3, 4, 5 only, right? We need that I only. And if you notice that fact is not increasing, fact is just nothing. It's not increasing, right? I is also only increasing. So what is the thought process here? The thought process here is that fact is dependent on I, and fact is 1. Let's just forget about fact. Forget about this fact. Okay. Just think here that here we have I 1 and we have I here. Okay. Then this is also 1. But this 1 is changed by 1 into I. Then we're just going gradually moving again, right? And then we are upgrading this I, because fact and also we are upgrading this fact, right? So I becomes 2 and fact is again 1 times 2. Then we are upgrading again, then we are doing 1 times 2 times this one 3, this one 3, right? This one 3, because fact has become 2 and this one has become fact has become 2 fact has become 2 and this has become 3, then again 4, because fact has become now 6. Okay, this is 4, then fact has become this much, again 5, and this is, there was 1 before. That is the logic behind. Just move ahead. Okay, just a second. Yes, are I did not. Okay, I just need to do. Okay, man. This was lag. Now we'll just printf factorial of percentage d. We'll write here percentage d would be would be just n, and this would be fact. Just a second. And this one would be, and this one would be fact. We just enclose it with parenthesis and semicolon, and just stop this. This one and this one is connected because, right? So that's it. And this thing would not go here. It's not needed. It will just stop here. And that's done. Okay. That's it. Now let's solve some more question to bring the clarity. This would be equal to, but it's fine. And you can give a /n, or else that something like this, your username just writing it with your username with something location of the laptop, like abc/mkd.c. This would just come up with your answer, which is 5 factorial answer, which is what 5 factorial is 20 times 2 40 43 120. Okay, So 120 would be just coming up with this. If you just do slash and this would go here. Right, let's move on. I think you know it. Now %3. Oh. It's just %3 would be like this. We also have this here. Okay, I think you all may know Fibonacci, which is just 0, 1 at the start, then it would just get added up and it would form the Fibonacci series. Okay, then it would just added up like that. Okay, so now we have this. The Fibonacci sequence is defined as follows. The first and second term in the sequence are 0 and 1. Subsequent terms are found by adding the preceding two terms. Subsequent terms are found by adding the preceding two terms in the sequence fi equal to fi minus 1 plus fi minus 2. Write a program to find out the value of nth term of the Fibonacci sequence. So you have to find the value of nth term of the Fibonacci sequence by writing the suitable user-defined function. Okay. Let's actually solve this. So first we will write, this one would be compulsory, has to include studio.h. Then we will write int main function would include it will include int the number of terms, let's say n, and it should have mentioned int type enter Fibonacci serial number. Enter the serial number, right? Then just scan this. Okay. Now we'll just call a function, and it will be again void because we don't need to return it. Because why we don't need to return it? Because that's it. Because we're just finding out the value of nth term. You're just finding out the value of nth term of the Fibonacci sequence by writing a suitable user-defined function. Yes. So we're just writing. Why don't we need to return it? Because we're just writing. We're just finding out the value of nth term of Fibonacci sequence by writing a suitable user-defined function. And what is a suitable user-defined function? This is Fibonacci function. Now we'll just write void. And the function would be Fibonacci, which was present time of calling. Then we'll just declare it, because as I told you, the variable goes up but data type doesn't, so we'll just declare a variable. Then yes, and you should also know that when it is integer, when integer is getting called, the copy of the integer goes up. But when it is an array, whether it is 2D or 1D, actual that the address goes up, the actual value goes up, right? Let me read it out. from my note. टू डी अरे अडर को पास करते वक्त फ्रॉम वन फंक्शन टू अनदर, लाइक फ्रॉम मेन टू न्यू फंक्शन, उस समय रो कॉलम्स को अरे से पहले लिखना ज़रूरी होता है सी में। वो ये दिस इज़ डिफरेंट। ओके, जब आप n एक सिंपल इंटीजर भेजते हैं नए फंक्शन में फ्रॉम मेन फंक्शन, तो उसकी कॉपी जाती है, ओरिजिनल n नहीं होता। लेकिन जब आप एक अरे भेजते हैं तो सी अरे की कॉपी नहीं बनाता, वो सीधा अरे का एड्रेस, उसकी लोकेशन भेज देता है। तो अगर नए यूज़र डिफाइंड फंक्शन में कुछ चेंज हुआ तो सो इन द न्यू यूज़र डिफाइंड फंक्शन, तो नए यूज़र डिफाइंड फंक्शन में कुछ चेंज हुआ तो अरे विल गेट अपडेटेड। तो फिर से मैं पढ़ता हूँ, वो सीधा अरे का एड्रेस, उसकी लोकेशन भेज देता है, मतलब मेन से नए वाले। तो अगर नए यूज़र डिफाइंड फंक्शन में कुछ चेंज हुआ तो अरे विल गेट अपडेटेड। तो इस कारण से रिटर्न की भी ज़रूरत नहीं है, बिकॉज अरे पहले से ही अपडेटेड हो गया है। तो वॉइड से भी काम हो जाएगा, मीन्स कि हम वॉइड से भी काम कर सकते हैं, बिकॉज अरे इज चेंज्ड बेसिकली। इफ यू वांट टू चेंज द अरे, द एक्चुअल अरे गोज अप, so we don't need to return. Okay, let's move on. We just declared the array because we hadn't declared it before. Then we'll declare some variables equal to 1, because this one the first term, this one is the second term, right? Then we will just let's do it faster. Okay, for int equal to 0, I less than and I plus plus, if I is equal to 0, okay, if I is equal to 0, like I should be less than n. This means what? That we are mommy मगेडलू केट समय लागिव हाँ मगेडलू का कौन मगेडलू Okay, so guys, now I is equal to 0. So basically I is less than n. N is what? N is what? N is the entire number of Fibonacci term number, right? So we can term that sequence. Write a program to find out the nth term of the Fibonacci sequence by writing this. It will be defined function. Yeah, nth term. N is the nth term. It will be less than that, right? Because if it would be n minus 1th term, then only by adding all those n minus 1th term we will get the nth term, right? Right? Because by adding those, let's say we have to find fifth term. By adding all four terms, we will get fifth term. So we'll write here this much. We'll move on and write here our I, because we have defined the I n, and we have defined I also. We will write our I is equal to A. Continue. Okay, so what is this continue used for? Okay. Okay, so I also don't know what this continue used for. Just a second. Let me just. Actually, I just forgot why. Okay, why this continue used for? Let me ask. Okay. No. Yes. This one. Okay, so let me ask here why is this continue? Hello, I mean, so we will ask here what is the role. CD continue. Segment immediately skips the rest of the code. In the recurrent loop, raise and jump the next trace. Just a second, guys. So let's move on. And super okay. So in C, the continuous statement immediately skips the rest of the code. So in the C, continuous statement immediately skips the rest of the code inside the current loop iteration. Inside the current loop iteration, it skips the rest of the code and jumps directly to the next iteration, incrementing I. Okay. So here similarly, your RA is which is there is skipped, and we move to from I0 to I1. Right. In your code, it acts as a ground to ensure that the initial base cases I equal to 0 and I equal to 1 do not execute the general Fibonacci logic below them. In your code, it acts as a guard. Sorry. In your code, it acts as a guard to ensure that the initial base cases I equal to 0 and I equal to 1 do not execute the general Fibonacci logic below them. What happens in each case? When I equal to 0, R0 gets set to A0. Continue triggers, it skips if I equals 1. Okay. And the general addition logic below immediately jumping to I equal to 1. Continue triggers, it skips if I equals 1, and the general addition logic continue triggers, it skips if I equals to 1, and the general addition logic below immediately jumping to I equal to 1. When I equal to 1, R1 gets set to B1. Continue trigger, again it skips the general addition logic, jumping the code to I equal to 2. Okay, so if I equal to 0, if it is not, then okay, if it is, then it will just execute this, then okay, so we have to take some examples, right? Take some examples. So if Ri equals to A, Ri equals to A, if I equal to 0, Ri equals to A. Okay, let's say n is 5. We have to find the fifth term of the Fibonacci sequence, right? So it will just do 0, 1, 2, 3, 4, right? Okay, so when I tell fifth term, it means okay, if you see here in the question, if Fibonacci sequence is defined as follows: the first term and the second term in the sequence are 0 and 1. Subsequent terms are found by adding the preceding two terms in the sequence. This one, write a program to find out the value of nth term of the Fibonacci sequence. Write the program to find out the value of write a program to find out the value of nth term of the Fibonacci. Nth term means what? So if the second term here is 1, sorry, the second, if the No, basically what I'm telling you is, does C language takes the first term as 0th index. So if I is equal to 5, these are, so if I so it will go up to 124. If I equal to 0, which it is, Ri would be equal to A, means 0 would be equal to A, which A is what? A is 0. Continue, you would just go move on, because I would be equal to 1. Okay, I don't think this is a good example to set, right? Let's actually take this and write it here. Yes, okay, so it's true. But why do we need this? Not let. Okay, just a second. Stop. Write the C program. Okay, so hashtag include studio.h. Okay, I think this was better, right? So you notice in series 0th index means the index count starts from at 0 instead of 1. Just read this once. What happens in each case when I equal to 0, R0 gets set to equal A0. Continue triggers when I equals to 0, R0 gets set to A0. 0 means what? The value is 0. Continue triggers, it skips if I is equal to 1. So if I is equal to 1, continue triggers, it skips. Continue triggers, it skips if I equals to 1, so it will skip this whole thing. The jumping general addition logic below. The jumping general addition logic below and the general addition logic below. Let me just check it. Yeah, so this is completely right. Yes, so inclusion is completely right. When continue is triggered, it jumps back to the top. Okay, so this is what we need. Okay, yes, so inclusion is completely right. When continue is triggered, it jumps back to the top of the for loop header. Just a second, man. What is happening? Yes, setting is 50. Yes. Okay. I was telling you, as introducing complete right. When continue is triggered, it jumps back to the top of the for loop header to run the updated step I++. Here's here's the exact step-by-step mechanism of how I uses and the code executes. Step-by-step flow. At iteration I equals 0, it loop starts with I equals 0. It evaluates if I is equal to 0, which is true. It sets 0 equal to a if it's continue. If it's continue, what continue does instantly? It skips all the remaining code down below. Okay, so it skips so it skips all the remaining code down below it jumps straight to the I++ part inside. For int I equal to 0, I less than n I++, I becomes 1, right? So just see this, I becomes 1, and after I is 1, it checks if I is less than n, which is true. If true, it begins the next iteration, right? Iteration 2 I equal to 1. Now I is 1. Now I is 1. It reaches if I is 0. Since 1 is not equal to 0, yes. Now iteration 2 I equal to 1. Now I is 1. It reaches if block I is equal to 0. Since I is not equal, since I is false, it skips this entire if block completely. It moves to the next statement if I is equal to 1. To move to the next statement if I is equal to 1, which is true. It sets RA1 equal to B. It sets what? It sets R1 equal to B. It sets R1 equal to B. Sets R1 equal to B. It reaches if I is equal to 0. Since the 1 is equal to 0 is false, it skips this entire block completely. It moves to the next statement if I is equal to 1, which is true. It sets R1 equal to B. Right? Let's continue again, jumping back to the top of I++, making it I2. Okay, so that's it. Right. Then after doing this, it hits false here again. It hits false here again. Then moves here. Ri, which is 3, is equal to A plus B. And then what happens is B becomes A, right? B becomes A and B, no, not B, A becomes B. Okay, let's say this is okay. Obviously A was 1, B is 0 initialized. We have initialized as these two. If A was 1 and B, sorry, A was 0 and B was 1, then A becomes 1 from 0, and so basically what is happening, see, if A was 0, so this is A, let me just write it here, 0, 1, 1, 2, 3, 5. Okay, so if A was 0, so if here I'm telling you, so from this line what do we mean? We mean here A is 0, right? This is A and this was B. Then now what has happened? A has become B, so this has become B, and B has become Ri, right? So basically it was Ri was addition of the 2. But is this right? Because we needed a third. So basically we needed the what? We needed a third term. We needed a third term. But is the second term, right? Because 2 can be less than 3. If we needed the third term, so 2 should be less than 3, and 0 1 2, basically 2 is actually third term, second index is actually third term. So whenever this becomes this, it will stop. So if 2 is okay, so if we just see here this one, just see the curly braces, it starts from here and this one ends here, this one ends here, this one doesn't end, starts right. As it starts and ends. Which one ends? Which one ends here? Okay, actually, let me just, I'm just not sure about this. Just copy this once. Man, let me just copy this once. Then let me just go here. Gedit p1.c. If you just see this one, it ends here, right? But if you just see this one, it ends here. But what about this? Oh, it starts from here. Okay. Then what about this? Actually, we don't need the curly braces here because it's not if block. When I is equal to 2, right? When I is equal to 2, it skips this one and this one. It goes here. A plus b becomes R2. But is it right? Yes, it is right. It is actually right. If you see, if this is the second term, right? 0 plus 1 is 0, 1. So it is right only. Then B becomes A. Basically, the 1 goes to the 0 and the A part and the B and the Ri, which is 1, it goes to the B. So basically there is a shifting taking place, right? Before it was this, now it has become this, then it would become this, then it would become this, and we'll get this, right? But it doesn't matter. If you want to find R of 2, which is, sorry, if you want to no, I'm right. If you want to find R of 2, which is actually the third term, right? Isn't it the third term? Because 0 1 2, this is actually third term. So if you want to find R of 2, which is third term, then you just need 0 and 1. 0 plus 1 is 1. So even if we are indulging with, if you are changing the A and B, nothing is harming us because it will then go here and it would see if we just increment it by 1, it will just stop and we'll just get this one. And we'll just print a Fibonacci number is Rn minus 1. Rn minus 1 is what? Rn minus 1 is basically the term which we want, which is like okay, basically it's Ri, Why we can't try, we can write ri also in place of this, because again, no, we can write it actually, because I would be here 2 and n minus 1, which is 3 minus 1, is again 2. So I think both would be same. It would be Fibonacci number. And if we want to just find it out, GCC, let's check if it is correct or not. Oh man, it's wrong. What the hell? So wrong. Shit. Okay, if we just try to actually run dot as a dot out. Oh man, it's actually wrong. Okay. Man, how can he write it wrong? Okay, so okay, where is it? It is a mistake, I think. Is it here? I don't think it's here. Just okay, I think the mistake was here. I think I didn't copy it well. Actually, it was my mistake. Still, it's wrong in function main. Return 0. What did I make wrong? Okay, I think I didn't put this. Mouse isn't working well. Okay, so I didn't copy that also. So yes, that was the mistake. Come on. Yes. I think now it would be right. Should be right. Yeah, if we enter 5, we'll get the answer 3. And it is actually 3. 1, 2, 3, 4, 5. It's actually 3, right? Because you have to add the 4 terms 0, 1. 0 plus 1 is 1, 1 plus 1, 2, 2 plus 1. 0 plus 1, 1, 1 plus 1, 2, 2 plus 2, 4. Sorry, 1, 1 plus 1, 2, 2 plus. Sorry, I'm again sorry. 0 plus 1, 1. 1 plus 2 is 3. Okay. Am I wrong actually? So let's continue. Right. So if I just change this to I, it would be same. Okay, it will be same because I would be 1. Let's see again, doing the same thing. Sorry. Check it out. 1, 5. Okay, the answer is same. So both will be same. You need to. Okay, did I saved it? I think I saved it. Yes, I think both is correct. Okay, I should actually do GCC, right? 5. 3, just GCC. Okay, I didn't do the GCC. Rise and declared. First use this function printf Fibonacci number ri. So rise and declared first use in this function. Yeah, how is I undeclared? Because we had declared it. Declared it before, right? Okay, let's see the mistake. inputs. Okay, let me just check once more. Yes, so let's make you a bit more clearer. Define the first and second term. Okay, so just note this sequence fi equals to fi minus 1 plus fi minus 2. Right. Okay, what's the mistake here? Just a second, guys.